Okay, your stuff up from yesterday. Let's take a look at what we've got. This is what I gave you to practice yesterday. I wanted you to spend some time isolating things and solving for things. This was the page. Here are the answers to that page. Here's the top chunk. Questions, comments, concerns. Is there anything anyone wants me to do or demonstrate from this page? There is quite a look. This one empty? Nope, this is my physics plot. Okay. There's nothing anyone wants to see me do. So it means you all got them all totally easy and fantastically simple. Wrong class, sir. I will see you next block. Nothing. There's nothing anyone wants to see. You're cool with B. B was or 2B. This one was the one that everyone every semester freaks out about. I've had students drop the course over this question because they were like, if it's going to be this bad, I'm done. I'm like, whoa. It's not going to be this bad. Relax. But is there anything anyone wants to see? You've all got the math skills. If you took regular math 10, you have the skills. You just might not know how to put them in the right order, and that's fine. We can work on that, but the mathematical skills are there. If you took Foundations 10. Okay, nobody wants to see any of those things. Okay, so then here's the bottom chunk. Those are the answers that I got. I rounded a couple places. I mean, 3B is not 4. Technically, it's 3.99. But what's a centimeter? When you're 4 meters across, or 3.99 meters across, a centimeter is just basically error, which we're going to talk about hopefully today. We're going to talk about error. It's going to be great. You're not perfect, Sienna. And we're going to expose it. That's what I mean. That's error. You're not perfect, and we're going to talk about it. Except all of you aren't perfect, and that's what we're going to talk about. It's not just you, Sienna. Okay. Comments, questions, concerns on any of that? Like I said, this algebra is probably the grossest you're going to get all semester. It does not get worse than this. It does not. I don't even think it gets this bad. Comments, questions. Really? Nothing? Is it just because it's a Thursday morning and we're all tired? So you have questions, you're just too tired to open your mouth and ask them. That's really unfortunate. Should you wake up at some point in the next couple days and want to go back to this page, let me know. Otherwise, let's talk about some trigonometry. Okay, trig review. For some of you, trig was a long time ago. If you didn't have Math 10, or if you had Math 10 first semester, and then don't have it again until next semester, it's been a little while. And that's okay. Let's talk about trig and all the things related to trig. There's two pieces that we're going to need kind of fairly extensively, and it's all kind of lumped in together. Call it trig. The one on the left is the Pythagorean theorem. What's the Pythagorean theorem? A squared plus B squared equals C squared. A squared plus B squared equals C squared. What is A? What is B? What is C? Just make sure we're all on the same page, bringing all the memories back from grade 8 or whenever you first learned this. How do you label the triangle? Yes, Levin.
It's always the one. So in front of the 90.
Yes, yeah. The angle, the 90 degree? Yeah. So this is the 90. Side C is always the side across from that. And it's the only one you actually have to label. A and B don't matter. A and B are just the other two sides. So this one could be A, and this one could be B, or this one could be A, and this one could have been B. It doesn't matter. The only one that matters is side C. Now, for those of you who... What course is it? You would have done it in pre-dip. If any of you took pre-diploma 10, There is an extension to the Pythagorean theorem. What does the Pythagorean theorem extend to? You forget? It starts with c squared equals a squared plus b squared, but then it keeps going. It does. You pre-calc 12 should absolutely know what I'm talking about. You've forgotten. Shame. For those of you, just fun fact, for those of you who have seen this before, c squared equals a squared plus b squared minus 2ab post big C. You've seen this? Cosine law, for those of you who have seen it, is just the Pythagorean theorem all fancied up to take out to wherever, not just right triangles. It just so happens that in a right triangle, which is all that we're going to deal with this year, you're going to have the fun triangles next year. All that we have to deal with is C is always across from the 90, and the cosine of 90 is? Those of you who've done this before? Nope. 0. It needs to be 0, because if it's not 0, then the Pythagorean theorem needs to include this. If the cosine of 90 is 0, then this is gone, and all we're dealing with is c squared equals a squared plus b squared. So the cosine law is just the fancy Pythagorean theorem in its full form. You will not need cosine law this year, but you will absolutely need it for Physics 12. Okay, so that's the Pythagorean theorem. You've seen it before. What are the trig ratios? We only need 3 of them. There are like 9 of them, but you only need 3. There are 9. There are 3 I've never used, and I have a master's in this stuff, so I think engineers use the weird ones, hyperbolic ones that I don't use a lot of. Hyperbolic? Yeah. Okay, when I say trig, the first thing that comes to your mind is? No, there it is. Apparently it's not the first thing that comes to your mind. SOHCAHTOA. And for those of you who it's been a while, this is I don't know if the acronym is the right word. This is the mnemonic device that we use to help remember how these things all go together. So this means that sine of some angle is equal to the opposite side over the hypotenuse. Ka gives you that the cosine of some angle is equal to the adjacent side over the hypotenuse. And TOA is that tangent of some angle is equal to the opposite side over the adjacent side. And those are all dependent on whatever angle you choose to start with. So if this here is theta, then opposite, adjacent, and hypotenuse are which sides? Sorry? This guy here? There's your hypotenuse. Straight across is your opposite side, and adjacent means beside. So it's going to be that guy down there. But that's not the only angle we could use, right? We could go up here. If this is the angle that we're going to use, the hypotenuse stays the same and you swap the opposite and adjacent side. Opposite is always across the triangle. That would be opposite if we're going to go with the green angle. And then this would become adjacent if you're working with the green angle. For some reason, for some students, this just takes a little while to click, and that's fine. So one of the things that you would have done in grade 10, kind of the end, when you first introduced to the, yes, Andrew? Then the hypotenuse is the opposite. It's also the hypotenuse. So you'd get hypotenuse over hypotenuse, which is why the sine of 90 is 1. And if you shove the cosine in there, then you've got the adjacent side is both of them, which is why cosine is 0.
Let's say the obtuse or an acute angle, but it's not a 90-degree triangle.
Then you need the sine law or the cosine law, and we don't care about that. You will not be using that this year. You will look at, like, that's what you need. So this guy, when I said we're going to save him for grade 12, if you're dealing with anything that's not right angle, and you will do that next year, there's a whole section of Physics 12 where you're adding vectors together, which we will talk about what a vector is, but you have to add them together in weird ways. That's where the obtuse and acute are going to come in and bring in the cosine law. We're not doing that this year. So, when in grade 10, kind of the end of trig in grade 10, yeah, you have to do some of that sine law stuff. But the end of the basic trig section is something like this. Solve the following triangle. They give you a triangle, you'll have two pieces of information, and they'll say solve it. And solving a triangle means what? Finding everything you don't know, sides and angles. So let's label all the things we don't know. We don't know that guy, X, we'll call that guy Y, we'll call that guy Z. And trig doesn't care what order you solve these things in. If you have two pieces of information, you can start anywhere. So, Abdu, where do you want to start? There is an easiest place to start in this particular example. We can start with Y. You want to start with Y? Sure, start with Y. That's not the easiest place to start, but that doesn't matter. Let's do it. So if Y is the place you want to start, we have to look at the information you have. What information are we given, Abdu, for Y? Okay, we're given that angle. What is side Y relative to that angle? How would you label side Y? It's across from the angle that we're working with. So we have to use, so this is the opposite side, and we're given the hypotenuse. So how are you going to go about solving for? We're going to use sine. So sine theta equals opposite over hypotenuse, and now we can fill the thing in. The sine of 30 is going to equal the opposite side, the y that we're looking for, over the hypotenuse, which is 12. And now we can go ahead and solve this thing. We want to get y by itself. It's nicely nestled in the numerator there. How many n-words can I throw in a sentence? So how do we get it out? How do we get it by itself? Kiana. Good morning. What's your favorite soup? Ooh, good choice. How do I get y by itself? Okay, some of you are punching things into your calculator, so clearly you know. How do I get y by itself? Abdu, what are you punching into your calculator? Yes, Levin. But why? Hey, we're multiplying to get rid of the 12 in the denominator. Thank you, Levin. So now that's what you're going to punch in your calculator, 12 times sine of 30. For those of you who have done the triangles before, and you've turned the triangles into circles, and you've looked at those special relationships, you know that the sine of 30 is a half. Half of 12 is 6. If you don't know that, that's fine. 12 times the sine of 30, will you punch into your calculator? Those of you in grade 12 who are in pre-calculus 12 right now, so at some point in the semester, you guys are going to do a unit of trig in 12. And if you're in IB, any IB year 1 math students? Okay, then it's the pre-calc 12s. At some point, you're going to jump into a trig unit. And you're going to learn all about something called radians. Radians is an alternative unit for measuring angles. Your calculator deals with radians and degrees differently. In that class, you're going to have your calculator in radian form. When you come over here, you need to make sure you swap it over to degrees, because if I'm in degrees, I'll show you what this looks like, and I want 12 sine 30, there's a little d there on the screen. It'll give you the correct value. I'll zoom in so you can see what I'm talking about. Your calculator should have a D there, or wherever it is like all of you, or it'll say DEG. Make sure your guys' calculators are in degree mode, because there is another set of units and you don't see them until pre-calc 12 or IB year 1. But if you have them, how do I change it on this calculator? I go mode. Do I go, nope. Nope, I go setup. There we go. Radians. Now I'm in radians. If you punch the same thing into your calculator, 12 times the sine of 30, it is not going to give you a value that makes sense. Negative 11.85. How is that a negative length? What does that even mean? But if you don't stop to think about it, especially on a test, you'll just be flying through it, shoving things into radians, and you won't even think about it, and then every single value will be wrong. I have had this happen more than once where I then have to go back and I change my calculator into radians and I redo all my calculations because I don't want to punish you for not having your calculator in the right mode. But do be aware, especially you two in Pre-Calc 12, that is going to happen at some point in the semester. You're going to swap over in that class. Make sure when you come here, your calculator's in the right mode. Andrew.
Explain why the radians mess it up so much behind it.
There's a relationship between degrees and radians. I mean, Sienna put it really well when she walked into class, and most of you guys weren't here. She said with trig, you start with triangles, right triangles, and then every triangle is a right triangle because you bring in the sine law and cosine law. And then every triangle is actually a circle. And that's where you jump into radians and you start looking at where you are on the unit circle and you start graphing these trig ratios. And you start to get those sine, cosine, tan, or the sine and cosine waves, and the tan does weird things. And yeah, it's a different way to look at those same angles. And so the numbers have to be different. Okay, so Abdu, you wanted to start with y. Did we have to start with y? Where would have been the easiest place to start? The angle. If I know two angles, then what do angles in a triangle do? We're going to make a little note here. Angles in a triangle add to 180 degrees. That is a rule for all time. We love triangles. So we could have started just with Z. Z is going to equal 180 minus 90 minus 30. 180 minus 90 is 90. 90 minus 30 is 60. And then if you had started with Z, now we've got a 60-degree angle there. If we then move to finding y, do we have to use sine? Do we have to label y as the opposite side? No, Violet says, shaking her head vigorously. We could have started with z, and if we're going to use z, then y is actually what side would y have been as it relates to that angle instead? Someone just say it. Jedediah, say it. It's the adjacent side. And then we would have, instead of using sine, we would have used cosine. So the cosine of theta is equal to the adjacent side over the hypotenuse, and you'd have the cosine of 60 now is equal to y over 12. So then y is going to equal 12 times the cosine of 60, and you'd still get y equals 6, because the sine of 30 and the cosine of 60 are the same. The thing that in my experience teaching Math 12 or Math 10 that students hate the most is there is not one way to do this. If you have multiple pieces, you can choose your own adventure, and if you give students too much choice in math, they freeze, is my experience. Okay, so let's go ahead and find x. If this is the order we're going in, how could I find x? Someone give me a way to find x. Sorry? We could use sine. Okay. If you're using sine, what angle are you using? To find x? Okay. If you're using this angle right here to find x, x becomes the adjacent side, and now you're using cosine. So you'd use the cosine of 30 is going to equal x over 12. That is not the only way to do it. Okay, gentlemen, at least whisper, please. Someone give me an alternative way to find x? Andrew.
You can use the a squared times b squared equals c squared, but you have to do it to a squared.
You could use the Pythagorean theorem. You could say a squared plus b squared equals c squared. Let's call x side a. You could call this x squared plus. Now we've got a value for b. If x is a, then y is b. And that's 6 squared equals 12 squared. And you can keep going and solve that. You betcha. What's the other way to find x? Because there's a third way. There's actually 4 ways. You could use tangent. If I want to use tangent, it doesn't matter if you use the 30 or z. You could do it both ways. Oh boy, you want to use tangent? Okay, cool. The tan of which angle are you going to use then? The 30 or the 60? Oh boy. The tan of 60 is equal to the opposite side over the adjacent. Ooh, that is the right choice. Because that puts x up there in the numerator over y, which is 6. Or we could have done it, the tan of 30 equals 6 over x. Or, there's actually a 5th way. We could have used what? What's the one ratio we haven't used yet? No, we've had tan twice right there. The sine ratio. We could say that the sine of, what are we using? This we haven't used yet. The sine of 60 equals x over 12. And it doesn't actually matter which one of these we use, because they're all going to compute to almost the same thing. We still haven't found x, so what is it? Let's punch all of these into a calculator. To get x by itself, here we're multiplying both sides by 12. So 12 times the cosine of 30. Oh, I'm still in radians. Classic. Boom. I've got x is equal to 10.39 if I do it that way. If I do it here, and I'm solving this, I'm going to have 12 squared minus 6 squared, and I want to square root that thing. I'm going to get 10.39. If I do it this way, and I want to get x by itself, I'm going to multiply both sides by 6. And so I'm going to have, I should actually be doing this right here. I'm going to have 6 tan 60. Boom. It's still 6 root 3, which is still 10.39. This one is the only one here that really does truly suck. You got to be really careful when what you're looking for is in the denominator, because you actually have to multiply the x up. Multiply both sides by x. If your variable's in the denominator. This is why we show our work, Andrew. And then you're going to divide both sides by the tan of 30. Something that you would have seen last year. So then to find x, that's going to cancel. And you're going to have 6 divided by the tan of 30. And oh look, it's still 10.39. It's kind of hard to see with the way that light goes. There we go. And then the last one, 12 times the sine of 60. It's still 6 root 3, which is 10.39. Those of you who have a calculator, a Casio, or who have done enough math to use the special angles, don't use 6 root 3. Call it 10.39. In physics, we like to round because those decimals actually have more meaning. What is 6 root 3 meters? I don't know. What is 10.39 meters? Oh, that's 10 meters and 40 centimeters. The meaning there is clearer when we use decimals, even though it's not exact. All of this to say, what's the old phrase? There's more than one way to skin a cat. The old school phrase. My dad used to say it all the time. There's more than one way to skin a cat. I'll take your word for it. I've never skinned a cat, but
The other ones.
I don't know. I don't know any of the ways to skin a cat. Apparently there are more than one. There are 5 ways to skin this metaphorical cat. So It doesn't matter which one you do. I will never expect to see this. You just pick one and roll with it. For like, I have my own neurotices. I would do this every time. If I could. I don't know why. I don't like cosine. I don't like tangent. I like sine. It's totally arbitrary. It's like I only set my volume to 5s and 10s. 7 if I absolutely have to. 3 is okay, but 2, 4, 6, and 8? Garbage numbers. I don't know why. Pick a method and roll with it. Okay. I would like you... Oh, there's one more piece of information one more piece of language we need to look at here. The first two questions. They use the language of angle of elevation and angle of depression. If you start a trig question that doesn't give you a triangle and wants you to draw the thing, and your drawing is wrong, you're screwed before you even had a chance to succeed. So, let's look at the language. What is an angle of elevation? You're going up from where? I mean, elevation, typically you think of rising. And so the way you want to draw these things every time, the angle of elevation one's a lot easier. You want to imagine that you're looking straight ahead and then up. So the angle of elevation, you're looking straight ahead and then up. And that right there is going to be the angle of elevation for your triangle. When we talk about depression, when you are depressed, you are down. When you depress something, you push it down. So you want to think of it the exact same way. You want to look straight ahead and then down. So straight ahead and then down. And it's this angle right there. It's always the angle between where you started looking and then the direction you went. So either straight ahead and down or straight ahead and up. One of the things I see students do all the time is they call this piece the angle of depression, and that's going to screw you up. Angle of depression, again, go through the motions. Straight ahead and up, there's the angle. Straight ahead and down, there's the angle. Okay, I got 7 questions there because I do want you to do the bonus one as well. It says bonus. Do it. It's tricky, but do it. I'll give you some time to play with the trig. Make sure we're all on the same page. On your mark, get set, go. Let me know if you need a hand.